All right, Dragons, it's review time. Here are your questions for the upcoming Unit 7 test. In this particular problem, number 1, you notice you have a linear table. How do we know it's linear? Well, if we look at that little word right there, it tells us that we're dealing with lines. So as we look at this problem, we need to think of this as the first column being our input, and these two being my simultaneous outputs. Okay? So what we need to do, in my opinion, the quickest way to do this problem is to take a look at our systems and solve it for y and see, plug it into our computer and see, calculator, and see which of these two equations will produce this table. You could also do a linear regression where you input this data and ask the calculator to do a linear regression. If you remember those keystrokes, fair game, go and do it. But if you notice over here, these are in standard form. They're not in slope-intercept. So you're going to have to do some solving for y sooner or later. So if we look at the ones that have a plus in front of the y, it's really simple. What we're going to do is we're going to come over here and say, all right, this term, this negative 20x, needs to go to the opposite side. So currently it's negative 20x on the left side of the equation. If I move it to the other side, it becomes a positive 20x. Everything else stays put. And that was a pretty easy shift to slope-intercept form. But I need for y'all to look at this right here. This next one, if I just say, all right, this is the positive 21x on the left, it will be a negative 21x on the right. But I still have work to do. You notice, unlike the first equation that had a plus sign in front of the y, this one has a minus sign in front of the y. So once I move this 21x to the opposite side, I now have the opposite of y, because anytime you multiply something by negative 1, you're actually taking the opposite of it. So there's really a negative 1 right there. You can put that in there or not. So I don't want the opposite of y. I don't want negative y. I want positive y. So at this point, what you need to do is, in your head, divide everything by negative 1, and that's going to switch the signs. Or you can think of it this way. I want the opposite of a negative y. Well, that's a positive y. Well, if I take the opposite of one term in an equation, I need to take the opposite of everything else. The opposite of a negative 21x is a positive 21x. The opposite of adding 20 is subtracting 20. So now you notice I have both of the equations solved for positive y, not negative y. So make note of that on your paper. You can't just leave it right here and say, oh, I solved for y. No, you didn't. You have the opposite of y. Now, to save time, when I went through and I did the same thing for everything else. Now make sure that you study how I got these before you go on to the next problem. And once again, you can see that in the problems where there was a minus sign in front of the y, I still shifted the x term to the other side. It was positive 21x here. Now it became negative 21x on the right hand side. But I still had to take the opposite of everything. So the opposite of a negative becomes a positive. The opposite of a negative becomes a positive. The opposite of a negative or minus becomes a positive or plus. So you notice right here, this is just different systems of equations. Notice the prevalent numbers are 20, 21, and 126, and they just change the signs on us. So we got to go through two at a time in your calculator, check these out, and see which ones produce the table above. And after a little finagling and trial and error, you're going to see that this is the one that works. So let's show that. I have it typed into my calculator. So you notice I have this guy right here, typed in y1 and y2, and I'll go to my table. At 7, an input of 7, I have an output of 120 for one player and 21 for the other. Huh, kind of like this right here. 7, 120, 21. So let's scroll down and check out 15. 15, I have 280 and 189. Huh, kind of like this right here. And if you check the other points, you can see that they all work. So the answer to problem number 1 is D. Nanny, nanny, boo-boo. I told you had to solve for y. Look at this. This is all just, do you know how to solve for y and plug it in your calculator? You've got to know how to do this. But I digress. Next problem says to use the graph below to identify the correct system of linear equations. Oh, they graphed it for us. Okay, so remember, it's these two guys form answer A, these two guys form answer B, these two guys form answer C, and the last two form answer D. So I know the spacing is kind of weird. All right, so this is basically, can you identify slope and y-intercept on a line? Okay, so let's look at this line that I will highlight. I'm going to change color. I'm going to go to pink. Can you tell me what the y-intercept is? Because it's all based on y equals mx plus b, isn't it? But it looks like my y-intercept is 3. Okay, I'll put that right there. Need the y, need the x, need the slope. Can you tell me if that's positive or negative? And it's a negative slope. And so if I go down from here, it looks like the solution is 1, 1. Can I do a slope triangle? I'm going to go down 1, 2, and right 1. Down is negative, right is positive. Negative 2 over positive 1 is a negative 2x. All right, look at your answer choices. Where do you see a y equals negative 2x plus 3? Well, I see it right there, and I see it right there, and the other ones have a positive slope. So simply by looking at that, my pink line over here, and knowing how to do slope and y-intercept, we say bye-bye to A, we say bye-bye to D, because it has to work for both. All right, so we go to the other equation. So now we've got to look and say, well, can we just find how about the y-intercept? Is it 1/2 or is it negative 1? Because we already know that this right here is the pink line. So these other two right here have to be this one that has not yet been colored. If you look at the y-intercept, it's 1/2. It's this guy right here. The answer is going to be B. Now, if you really want to make sure, they cross at what point? Cross at 1, 1. So if you have an x value of 1 and a y value of 1, it should work in both places. So if I quickly come over here, plug in a 1 for both x and y, because that's what my graph is telling me. Is it true? So does 1 equal a negative 2 times 1 plus 3? Plug that in your calculator, you'll see that the right-hand side is 1. 1 does equal 1, it works in this one. What about the other equation? Does 1 equal a 1/2 of 1 plus another 1/2? Well, that's a 1/2 plus a 1/2 is 1. It works for both of them. So we quickly verify that the answer is B by plugging in the visually known solution. All right. I'm not in my workshop anymore. I'm at my desk. See the nice... Anyway. Here we go. Which graph represents the inequality 10y minus 18 is less than negative 3x? All right. Looking at these answers, you should be able to eliminate 2 of them simply by knowing if it's solid or dotted. Man, this time is going by quick, so maybe I'll get 3 problems at a time. I must be doing a really thorough job. Okay, so if we look at this sign right here, it's less than. Is that a solid or dotted? Less than. It's dotted. I know this problem has to have a dotted boundary. Well, A has a dotted line, B has a dotted line, but look at C and D. They do not. Boom. You're gone. So as I look at this right here, I need to quickly double check solve for y and make sure that I'm not going to divide by a negative, because remember, if I divide by a negative, this is going to switch. So I'm going to solve for y. I'm going to add 18, so that becomes 10y is less than negative 3x plus 18. Remember, if it's negative on the left, it's going to be positive on the right. And I'm going to divide by a positive 10. Dividing by a positive does not switch the inequality symbol. All right. So, am I shading above or below with a less than symbol? I am shading below. That is this way right here. The answer is A. And you can circle A down here as well.